Hey everyone, it's Mrs. Fellon again. We're here to do lesson 4.3, which is about rotational symmetry. And so we're going to talk about rotations and how to provide a transformation on a function or on a figure using rotational symmetry. All right, so what we're going to start with is number one, you're going to need your note card, and we're going to also start on page 105. Actually, no, I lied. 104 is where we're going to start. 104. All right, so there are some vocab words that we're going to start with. And so what we're looking at here is just kind of what is a rotation, right? So it's a kind of transformation. So remember, this is the third kind of transformations that we've learned. And it's a figure turn, it's rotated about a fixed point. So that fixed point could be the origin, and most of the time it is, but we call that fixed point your center of rotation. Your angle of rotation is kind of, so how I measure like angle of rotation is if, let's say for example, I don't know, you have a triangle here, right? And let's say this is A. And I'm probably not going to draw this perfect, but that's okay. So let's say we were trying to figure out the angle of rotation for this one, okay? And this is A prime. What you would do is, if we know that the center of rotation is at the origin, for example, you would connect like point A to that center of rotation, and then you would connect A prime to that center of rotation. And then whatever angle is formed here, and so this angle right here is 180 degrees. So this means that our angle of rotation is 180 degrees. It takes us 180 degrees to kind of rotate it this direction. So that's kind of what we're going to be doing today, kind of focusing a little bit on that. Rotational symmetry is a figure in a plane that has rotational symmetry when a figure can be mapped onto itself. So think about like if you look at like a flower or something else like in life that has rotational symmetry. As long as it has like the same image, that you can kind of map it onto itself. And this is a terrible drawing, but I'm going to try to draw like a little pinwheel type thing. So if I rotated this three different times, if I rotated this figure right here, like this one right here, and moved it to the top, it would look exactly the same. That's what it means to be mapped onto onto itself. And then a center of symmetry is just kind of the same idea. It's mapped onto itself by a rotation of 180 degrees or less about the center of the figure. So you're talking about, because once we get more than 180 degrees, it's like redundant to talk about the symmetry, and I'll kind of show you some examples. But basically what we're doing here is we're saying, if I rotate this, how many different times will it kind of look like its same figure out of the 180 degrees? And we'll kind of talk about that here in a bit. And so what they're doing here is they're showing you kind of the angle or the center of that rotation. So remember I said you can connect like Q and Q prime back to that center and then measure this angle would be your angle of rotation. It works out really nice when the center of rotation is at the origin. If it's not, then you'd probably have to use a protractor to be able to measure that angle in there. All right, I want you to turn to page 105. We're going to grab your note card that we started the other day when we talked about reflections. And so these are my reflection rules. And now we're going to add on rotation rules. So we're going to talk about how to rotate a figure 90 degrees, 180 degrees, and 270 degrees. And so what we're going to look at is our coordinate points. And so we're talking about our X values and our Y values, and we're calling them A's and B's, just to kind of be consistent with the last time we kind of talked about that. And what we're going to be doing here is we are going to, basically with a 90-degree rotation is we're going to flip A and B. So we're going to flip your X and Y value, but we're going to multiply that Y value by a negative. And then if you notice, the 270 degrees is the exact opposite. We're going to flip the A's and B's around, but we're going to multiply your X value or your A value by a negative. The 180 degrees is kind of the oddball, right? So it's the different one. The A and B actually stay in the same order. So the X and Y really don't change spots. The only thing that changes is that you multiply both your X and your Y value, or your A and B value, by a -1. So these are the rules we're going to use as we do our rotations. All right, I'm going to do a few problems with you, and then I'm going to have you guys kind of use the rest as practice. So I thought it would be good to do the 270, and I thought I would do like a combo. So we're going to do a composition of one. All right, so the first thing I'm going to do is identify which rule it is that I'm using. And so I'm going to go to my little cheat sheet here, and I'm going to say, okay, 270 is B, comma, -A. I'm going to write that down. And then what I'm going to do is I'm also going to start by writing down the coordinates of my points. And so again, pay attention to the scale here. We're counting by 2. So this would be at the point 1, 4. This would be at the point 4, 3. C is going to be at the point 3, 1. And D is going to be at the point 1, 2. So next, what we're going to do is apply this rule. So I think it's way easier to do this without actually, physically rotating it yourself. You're going to apply the rule and then regraph. So A prime becomes, so your B value becomes your A value, and you multiply your original A value by a negative. So it becomes 4, -1. B prime becomes 3, -4. C prime becomes 1, -3. And D prime becomes 2, -1. So again, what we're doing is we're multiplying that original X value by a -1. It does ask you to graph your final image. So 4, -1, and then 3, -4, and then 1, -3, and then 2, -1. So there's my figure after I rotated it 270 degrees. So what you should be able to do here, let me make sure I label these. So 4, -1. So this is A prime, 3, -4. So B prime, C prime, and D prime. If you want to check your angle of rotation to see if you did it right. So again, we said if you looked at the directions, it said it was about the origin. Let's say you pick, for example, C. If you connected C prime back to the origin and then connected C back to the origin, since we're talking about a 270 degree angle, is this angle here 270 degrees? And it does, because what's left over is 90 degrees, and you guys know that there's 360 degrees in a circle. So that means if this is 90, then that has to be 270. All right, let me show you number 5. So number 5 talks about a rotation. So it's a combo, right? So we're doing a rotation and a translation. Number 4 has a reflection and a rotation. So we're going to I'm going to save that one for you guys. So the 90 degree one is -BA is our rotation. And so that's our rule, if you will. And so what I'm going to do is it's just a line segment that we're actually moving. So I'm going to start by ahead and listing my coordinate points. And then I'm going to go ahead and apply the 90 degree rotation. And so I'm going to get M prime, I'm going to get to be 1, and then -2, and then I get N to be -1, 3. So again, all I did is switch the A and B, but I multiplied the original Y value by a negative. Now what we're going to do is we're going to go ahead and apply the next transformation. And so the next transformation, and we're going to add 2 to our X's, so that becomes 3, and we're going to subtract 3 from our Y's. So if I'm going to add 2, and I get 1, 0. So 3, -5, and 1, 0. This is going to be my new segment. All right. I am going to pause just for a second, and I'll be right back.